Hyperbola, guys. Okay, as you see, we're going to be in 9.6 today, and we're going to look at, we've been talking about different conic sections, and we're going to look at circles and parabolas and ellipses and hyperbolas, just like we've done in the past, except now they're not going to be at 0, 0. So if you look at your book, which I've got opened here, it gives us our different formulas for translations. So you see we're using HK, just like we've done with absolute values or parabolas, or which we're doing parabolas again, any or square root functions, anything we've done in the past that we've moved it, we've talked about HK either as a center or as a vertex, or it's a special point. It's a beginning point, depending on the function we're looking at. So in this case, for like a circle, our HK is our center. And so again, it's always our opposite. So here HK would be our center. And so if it was x minus 2 squared plus y minus 3 squared equals 4 squared or whatever. I don't remember what I said now. Then h would be 2 because it would be minus, and k would be 3. For our parabolas, HK, again, here is just our vertex. If it's a y squared, then our parabola is going left or right. If it's an x squared, then our parabola is going up or down. And we're going to do an example of each here in a minute. Now for our ellipse, same thing's true. We've got our HK, that's our center. A is still our vertices on our major axis. B is the vertices on our minor axis. So for this one, your major axis would be around x. So it's going to be long this way. Where this one over here is your a squared, your bigger number, it's under your y-axis. So the long ways would be this way. Hyperbolas, again, HK is our center, and then our a value is your vertices, and we'll just kind of move off that. This one's going left and right, it's under x. This one would be going up and down, similar to this one over here. This is a y squared first. Let me move my finger. So these are our formulas. I will give you some kind of formula sheet, or let you make a formula card or something. We'll talk about it next time for your test, so you don't have to memorize all these. We'll also talk about our foci for these, and I'll give you all those formulas. So you don't have to memorize them, but you need to know, just by looking at them quickly, what our different shapes are. Just save time, if nothing else. So let's look at a couple different examples. So let me get some paper. So say I've got, let's start with a circle. Those are our easiest ones. Say I have x plus 5 squared plus y minus 1 squared equals 4. So here, first thing I need to do is find my center. So it's going to give me negative 5 and positive 1. It's always your opposite signs. So my center is at negative 5, positive 1. My radius, again, is the square root of this. Because remember, our formula is x minus h squared plus y minus k squared equals r squared. So my radius here is going to be 2. So it's the square root of this number. So my radius is 2. So let's graph that. So we've got a center at negative 5, 1. So I've got negative 5. I'll go down 1. There's my center. From that, I'm going to move 2 in each direction. So I moved 2 there. From my center, I'm moving 2 in each direction. And then graph my circle, and I'm done. So that's our circle. Center at negative 5, 1. Radius at 2. Those are our easiest ones. So let's do a parabola. So what if I have, say I've got x minus 2 squared equals 8, y plus 3. Okay, so in this case, I've got my x minus h squared equals 4p. Remember, our p gives us our focus. and we use it for our directrix, y minus k. So here my vertex is at 2, negative 3. And then we just need to find our focus. So I've got 4p equals 8. So divide by 4, p would have to equal 2. So p is we're moving from our center. So our p is not at 2. It is at, so my vertex is at 2, negative 3. This parabola is going up because it's an x squared and 8 is positive. So we're going to change our vertex, our focus is going to go up 3 on my y. So I have 2, negative 1 is my focus. So my directrix will move down, and it's going to give me y equal to, it's going to move down on my y's to negative 5. So if I graph that, let's see, what do I do with my marker? I've got my vertex is at 2, negative 3. My focus is at 2, negative 1. My directrix is at y equals negative 5, so it's down here. And remember, every point on our parabola is the same distance from our focus as it is to our directrix. So when we draw these, they're going to be the same distance, no matter where I'm at. So let's just plug in a point. Say, let's see, we need a point. I'll throw my pencil around. So x is equal to 0. If I plug in 0, I'm going to have 0 minus 2 squared equals 8, y plus 3. So negative 2 squared is 4. 8 plus 3. I could divide by 8, and that's going to give me 1/2. Subtract 3 over, it's going to give me negative 2.5 is my y. So it gives me 1 point. So at 0, my y value is negative 2.5. So I'm right about here, so it's pretty wide. So it's symmetric, so over here at 4, I'm there. Let's plug in one more point, just to kind of get our shape. Let's plug in negative 2. So if I said x is negative 2, and negative 2, let me do the same thing. So that's going to give me, oh, and I wrote 4s there, those should be 2s. I was ahead of myself. So that's going to give me negative 4 squared is 16. I divide by 8, it's going to give me 2. And then subtract 3 over, y is going to give me negative 1. So this one is pretty wide, because over here at negative 2, I'm down at negative 1. So go over 2, and I'm down here. So it's going to look like this. Okay? Again, if it was y squared, if y was being squared, your parabola would be going like this direction. This would be a y squared. This is an x squared, so it's going either up or down, depending on what the p-value is. Okay? So let's look at an ellipse. Let me erase this. So say I've got x plus 3 squared plus y minus 1 squared equals 1. It's over 16, and this one is over 9. Okay? Now my center again here is going to be at negative 3, 1. My major axis, this is a larger value, so this is my a value, or a squared. It's under x, so we're moving on either side of my x-axis by 4. So my a value here is 4, because you take the square root of this. My b value is going to give me 3, because you take the square root of that number. And so we're gonna move off our center 4 on each direction on x, 3 in each direction on y. So let's do that. So my vertex, if I move 4 in each direction here on my x's, it's going to give me negative 7, 1. If I add 4 to it, it's going to give me 1, 1. My co-vertices, I'm going to move 3 in each direction from my center on my y values. So if I add 3 to that, or if I subtract 3, subtract 3 first, I get negative 2. If I add 3, I get 4. Okay, so it gives me my, it should be vertices. My vertices, my co-vertices. Now I just need my foci. So remember, for these, our formula is a squared. This is plus, so there's kind of a minus down here. Minus b squared equals c squared. So here, a squared is 16, minus 9 squared, b squared is 9, equals c squared. So c squared is 7. So what I'm adding here, my c value, is the square root of 7. So adding and subtracting the square root of 7, which the square root of 7 is a little more than 2, we can say like 2.5. As long as we're just looking at approximates. So if we wanted to, we could be exact and say our foci, and again, this is moving off of x. We could say it's negative 3 plus the square root of 7, 1, and negative 3 minus the square root of 7, 1, which that's kind of hard to graph. So, let's see, the square root of 7, I don't have a calculator here. It's about, we'll say it's about 2.5. It's actually probably a little more than that, about 2.6. But since we're just graphing, as long as it's between 2 and 3, we're good. So we can say we're going to add 2.5, that's going to be about negative 0.5, 1, and then we're subtracting about 2.5, so it'll be negative about 5.5 and 1. So let's graph these. Let's graph all these points. So we said my center is at negative 3, 1. My vertices are at negative 7. So we can kind of check ourselves. We can move 1, 2, 3, 4. That's at negative 7. And then move 4 this direction. 1, 2, 3, 4. And then our co-vertices, I'm moving 3. So I've got 1, 2, 3. 1, 2, 3, and then my foci, I'm moving 2.5, so 1, 2.5, something close to that, 1, 2.5. So I just draw my ellipse, and it's not super pretty, but that's basically our oval. Okay, so let's do an hyperbola. And then we'll talk about something else. So our hyperbola, say I have, just lump that up. I've got x minus 2 squared minus y minus 4 squared over 4. If I don't have anything here, it's basically like it's over 1. I'm going to go ahead and put that. So my center is at 2, 4. It's moving left and right on x because x is first. My vertex, we're moving 1. So the square root of 1 is just 1. So my vertices, we're moving 1 in either direction on x. So I'm going to have 1, 4 and 3, 4. So it's pretty close. The only other thing we need, well, we do need our focus too, but we need our asymptotes. So remember our asymptotes, we've got y equals plus or minus. My slope is the value that's under the value that's under y. So my b is 2, my a is 1, divided by the value that's under x. So it's y over x. So we're going to have b over a. So it's going to be 2 over 1 x, or just 2. And then my foci on this one, I've got a squared plus b squared equals c squared. So remember up here, I'll slide down. It was an ellipse. This value is positive, so this one's going to be negative for your foci. For hyperbolas, this value is negative, so this value is going to be positive for your foci. So when you plug them in, say I'm going to have 1 squared 4 equals c squared. so it's going to give me 5. So C is the square root of 5. And then we're just going to add, so our foci here, we're adding those on X as well. So it's going to give me, again, 5 is between 2 and 3. So I think this one is actually like 2.5, 2.6. So I would have 4, we'll just say 4.54, and about negative 0.54. Okay, so let's graph this one. So we've got all information. So my center is at 2, 4. So I've got 2, 1, 2, 3, 4. My vertices, I move 1 in each direction, so I've got 1, 4, and 3, 4. My asymptotes from my center, I'm going to move up 2 and over 1, down 2 and over 1. So I've got this dotted line. And then I move up 2 and over 1 this direction, down 2 and over 1 this direction. So remember, it kind of makes this little box with our vertices and our asymptotes. And so I've got this line. So these two asymptotes, and then, oh, I didn't graph my foci. So my foci, I'm moving 2.5, so 1, 2, so about right here. 1, 2, so about right here. So we just make it fit to our asymptotes. And that would be our hyperbola. Okay? So like I said, we've done all these before. All we're doing now is just moving off of our center instead of moving off of 0. So there's really not much of a difference. The only other thing is if our conic sections are not written in our standard form. And so if it's in general form, it's going to look like this. So let's see. It would look, let's see if I can get a picture. If I had an ax squared plus bx y plus cy squared plus dx plus ey plus f equals 0. So if I had it looking like this, we need to determine, well, first of all, which form are we in? Is this a parabola? Is it an ellipse, a hyperbola, or circle? A lot of times you can look at them pretty quickly and tell. I'm going to give you what we call a discriminant to tell us which one it, just give us a formula for each one, but a lot of times we can quickly look at it. If there's only an x squared or a y squared, then we're dealing with a parabola. It has to have both x squared and y squared to be either a circle, an ellipse, or a hyperbola. If it's missing one, then it's automatically a parabola. If for a circle, typically your A and C are the same thing. So remember, they have to have that same radius, so those need to be the same. Every once in a while we can do something weird and it will kind of come out to where they're equal,